Okay. I know that was only 5 minutes, but I want to intervene and ask how is the class writing things going? What functionality are you giving to your parking space?
I'm creating a vehicle-based class,
Mm-hmm.
and car and bikes are derived from vehicle,
Okay.
and register number,
Reached a number?
no number for vehicle,
Okay. Good. Good.
and the product number.
Cool. So if you scroll down, you can see a bunch of code here. Like here is a parking slot, and there is a park, and then an unpark, which you all, if you have written scripts, you know, right? And if you try to park on the same slot again, it will say, hey, you have already parked here. That's not fair, right? And if you try to unpark something which is already empty, that should also can also raise an error. I have not. But what's interesting is this is empty. And to find is if a parking slot is empty, I want to do something like, okay, first let's define the parking slot. I want to do something like Boolean of slot, like I would do Boolean of one, Boolean of a list. I want to do Boolean of a slot, and then it gives true, right? And everything is in the screen. It's not rocket science. You have everything in the screen. Why is this Boolean of slot working?
Because you have defined a bool there, right?
You mean here? Yeah. So that's the that's the answer. You have the answer right there. Now I've removed this, and if I run this again, it still gives true. Does that mean it's been defined there? Not necessarily. What is happening? So according to our logic, if a slot is empty, it should be true. If a slot is parked, it should be. So let's do slot dot is empty. So if a slot is empty, the bool should be true. If a slot is not empty, it should be false. But in slot dot is empty is false. Slot dot is empty is false. But still the bool is true. So we are very sure that it's not getting this value from here. Where is this bool of slot coming from?
We'll check the object is present.
Object is present. Not necessarily. Every class in Python also has a base class, like an object class. That object class by default has a bool method which you can do all the time. Doesn't matter whatever the class is, it keeps returning true until you redefine the behavior and say, hey, that's not right, do this. It will then start behaving the way you say. Now, if you have a parking slot which is occupied, it will also return false. So this is a very small behavior hack, but it's not really small, which is why I'm not going to care about unpark or anything. Let's go back to this section where, okay, where did classes go? Hmm, I'm not doing this. Hmm. In Python, everything is an object. That is like a given. Even when you do x equal to 1, it's an object. You don't trust me? If you have a class, let's say class student, and that looks like this, when you create an object, you mention the class and you pass variables. This is same as x equal to int of 1, right? This is just a syntactic sugar, but internally this is what's happening. So by that logic, int is a class because we define it, we kind of initialize it like a class. Not just that, if I do help of int, you can also find out that int is a representation of a class. Now everything is an object because every data structure is a class, right? Now, how does that relate to parking slot? That is what we are going to cover in a bit. Now, rather than using integer, let's say I'm going to create my own custom number. For example, in our case, we created a point class. Now, the point class had two parameters, self of x comma y. Now, x self dot x equal to x, self dot y equal to y. Now, this is a point class. I can make it look better using this representation thing and return of point of x equal to self dot x comma x equal y equal to self dot y. Okay, don't worry about the syntax and all. I'm just writing a class. See, there is still a mistake. Okay, cool. Now if I create a point object p, point of x comma y, sorry, x and let's say 10. X is there. Now this point, if I print, this is like this. This point is no different from this one, except that it's a class created by me, which is a class created by Python. Now I should be able to create more points like this. Let's say I create a point P1 and then with values 20 and 10. If I create another integer int of 20, 30, I am able to do x plus y, right? But when I do p plus p1, it says unsupported operand type point and point, which means the class I've written doesn't support this operand add. Similarly, I can do x minus y, which goes through fine, but when I do p1 minus p2, it doesn't. Even though I'm dealing with integers, which I know, but Python doesn't know. So you have to somehow make Python believe that all of these are possible. And that's where all of these dunder methods comes into existence. If you remove this, it's going to print still, but it's going to look very different. I think I have to rerun this. So see how ugly it looks. And this representation method is one such method, special method, which ensures that your print statements or the way that the object is represented looks pretty or looks evaluatable. What do I mean by evaluatable? If I pass this thing to an eval in Python, you will get the same object, like you will get a p object. Oh, it should be a string. If I pass the output of that thing, it will again give you an object. That's what representation should output. So that's just a segue. We don't need to worry about eval right now. We can still work with this point. Now the goal is to give all this add, subtract functionalities to this point. How do I do that? There are immense dunder methods. Now, how do I know what are those dunder methods that are a part of X? If I do dir of X, you can see all these methods that's been supported. Underscore mul for multiplication, any for negation, negative, or, and, radd, all of these functions are there. You won't use these functions when you're scripting, but when you're writing a library, you're giving a base value for something, you're going to rewrite this again and again. So let's give it add functionality of self. And then to this, you need to pass an other point object. You have add has two parameters to it. On the left, there is one, which is the self. On the right, there is P1. So let's say another point P1. So when you add, I'm going to do add x plus x, y plus y. So I'm going to return, and add should also return what? A point, correct? Because when I do x minus y, I get another integer. Similarly, I should return a point. So anytime you write a function, you decide what is the return value also. It should be a point. And to the point, every point object takes two values, x and y. In this case, self.x plus p1.x, comma, self.y plus p1.y. So that's the addition. Now, rather than saying plus is not supported, it will give me the final point value. I have to rerun the class and then reinitialize the object. When I do plus, it's giving me a new point where x plus x is done, y plus y is done. Now I have to find out p1 is greater than p. Again, it says that operand is not supported because it's a greater than operator. You also have an underscore dunder method for that, which is greater than, I think it's gt. Similarly, self.p1, self comma p1, and then this, what is the return value of greater than? If you do 1 greater than 2,
Boolean.
Boolean.
1 greater than 2, you get a boolean. It has to be a boolean. Let's do bool. So in comparison, I'm going to see x and y both are greater. If it's greater, like self dot x greater than p1 dot x and self dot y, the current points y is greater than p1 dot y. Right? Similarly, if you write a list L1, if you already have a list L1, I guess, no? Okay. We have a list L? No. Okay, 1, 2, 3. Let's say we have a list, cancel, 1, 2, 3. You can do len of L. This again is the result of one such function in underscore underscore. And that function, you can give it to this point. Again, point doesn't have a len. It has to be always 0. Point is just a point. So, but still, when I do len of p, it will give me that object has no length, like nothing like a length, but I can give it a custom function called underscore underscore len. And this one will always return 0. Right? Now I will create the point again. And then the length is always 0. So this is how you can give this custom class that you have created all the functionalities that the Python provides for its data structure. This is your custom data structure. You can give it division also. You can give it other things like bit length, denominator, numerator, R multiplication, R add, power operator. Power operator is your star star. If you do 8 power 2, this has 64. Similarly, you can give it other functionalities as well. So this is a very, very powerful feature. You will see it in every library that you're using if you go further. So I'll pause here if you have more questions and if you want to add more things here.
Bhavani, so here if you so you have written function for add and write, right? So the plus automatically uh, considers add function, calls the add function, right? So can I do like p dot add of p1?
Oh, like that, yes, you can.
Okay,
Like not just dot add, it has to be the underscore underscore add of,
okay,
yeah, because underscore underscore is a method. Dot add is not a method. Even if you do x dot underscore add, this is only valid. Add is not a method. We do only these are the methods that's available. Add is not a method. Does it make sense?
Okay, but how come length? Okay, okay, I got it.
No, length is a method that's available in Python as a built-in,
Yeah, I got it. Yeah.
as an object. Internally, it will call the object.length.
Mm-hmm.
And
Okay.
that's a syntactic way. So how do we bring it to a parking slot problem? That's where we started all of this, right? How do we bring it to a parking slot? Now I have a parking floor here. This is just, now if I create a parking floor P1, which has in here, I have number of slots. I'm not worried about what kind of slots it is. Let's say I have one floor with 100 slots. I have to create this again. And then I create another slot P2, which has I'm expanding my business. And then I'm adding a 50 more slot. Now I have to be able to find out what is the total number of slots that I have, right? So I should be able to do P1 plus P2. Now, for some reason, out of nowhere, something happens and one of my floor is not usable, or I have to stop using one part of the parking slot. I should be able to say, I know my P1 plus P2 is this much. I can also do P1 minus 5. How do I do that? Right side, we have always considered it's a point, but now you can also consider it's an integer. So this second parameter, you have always considered it a point, but Python doesn't stop you from sending an integer also. You can also work with integer. Similarly, you can write more things to, let's actually write that integer thing. Subtract, yes, sub. And then to a parking floor, I will subtract an I, which is an integer, return the self dot number of slots minus I. So this is my subtraction functionality that I'm giving, which means this should work. I will recreate the object and then I'll do minus 5. Now it has 95 slots, right? So this is a very powerful thing of functionality of Python, where you can make your custom classes behave like a Python's internal class, and you can use all the syntactic sugar that it provides. I'll pause for questions, and there's one more concept, a very important concept, after which we can wind up. Questions?
Okay, I have a question. So if you are familiar with JavaScript, like we can actually change the behavior of the current running JavaScript environment by changing the default functions. Like if you say you have say length function, so you can basically change that by changing the prototype.
Yes.
Can that be done via implementing this kind of things like which we are doing right now?
Actually, you can. But that has nothing to do with the way this is what we have
Yeah,
covered.
it's limited to the class that we have defined, right? But that can also be done, right? Like we can change the behavior of uh, the runtime that we have for Python.
Okay. Before we go to that, let's actually talk about this len, right? Len of L, len of 1, 2, 3. Now, len is a built-in method. Now you're asking if I can change the behavior of len itself.
Yeah.
How do we, although I'm very openly saying do not ever do this in Python. It's a start of all messes. Sometimes in older Pythons you were able to do it. Right now they are very strict in certain ways, but let's see. I'm creating a dummy len, right? And to this I'm taking an object, but this dummy length always returns 0. In previous Python, you were able to do it. Right now, I don't know. So turns out you can. Now to this length, now length has been redefined as this dummy length. Now do this if I pass every time, it calls dummy length, and then it,
Oh, so it has changed the behavior. Okay,
yeah,
nice. Cool.
you can do it, but don't do it.
Yeah, I got it.
Cool. So any other questions? If not, we can move on to functions. There's quite a lot in functions, which I'll try to cover. If not, I will send videos of all these sections separately, which is why I've skipped a few. And we might also run over by 15 minutes. Should be good.
Okay, there was this section in that method that you had created where you had removed underscore, right?
Yeah.
Um, there int and boolean were printing the similar uh, methods. So is it like boolean is kind of implementing int, or int is implementing boolean class?
You are talking about, I think, what's in the box?
Yeah, yeah,
This one, right?
yeah.
Boolean is extended from, sorry, integer extends from Boolean. One of those is true. I am kind of, let's actually try this. Might be wrong. Help of, yeah, Boolean extends from integer.
Mhm. So that's why like it has similar methods.
That's why it has similar methods, yes. And on top of that, it will have, I think it's all the same. Boolean also is an internal method. So
Okay,
cool.
cool. Thank you.
Now let's talk about functions. I'm not going to cover the basic functions. Very important thing about functions is when you're doing default variables, like any function can have variable. When you're passing default variable, don't ever use unhashable types or immutable types that we saw. Dictionaries, lists, sets are also an mutable type. So don't pass any of those as your default argument. If you want to pass it as a default argument, you have to do this, not this. And why is that? Is because of what happens. Like if I have a function A for which a default argument is this, the first, so inside this function, I print both the parameters and then I append something to the second argument. The first time nothing happens, no matter how many times I run this. The second time it starts appending, and then it keeps on appending to the same list. Now that is a problem. Yeah. Whereas when I pass a new argument like this, it doesn't happen. No matter how many times I run it, it's just the same parameter that I pass. It doesn't get updated. The parameter doesn't get updated. Why is that? Let's remove all of these so that it's better. So first time, let's redefine the function. The first time I run it, it's fine. It's 1, 2, 3. The second time I run it, the 100 gets appended, but that's not what I want. I want is this to be a default argument, right? Which means the second argument is something I'm not passing. But the same argument is getting updated again and again. Why is that happening? Think about memory management.
It's a global and local one. So when you pass it as a default one, it happens to be global memory, the global.
Right. That is exactly right. It is happening in a global level, which means the rest of the variables get populated only when the rest of the variables gets populated only when it's initialized, which means this param2 is initialized at the global level when the function is created, not when the function is called. So this param2 is created when I run the cell number 86, like that cell itself, param2 is created and a memory address for that is created, all of that is created. Whereas in this case, it's created at one, the local instance. Second, it is persisted only inside that block. And third, every time a function is ran, a new memory address gets created for values inside it, right? Which is why every time no matter how many times you run it, the value is always going to be same. It's not getting updated again and again. Super. So that is something with functions. Other functions you already know. So I'm going to skip this namespaces also. It's a very small concept that like we have just seen. Anything that inside a function is for that function only. Anything that's outside a function, you can also refer it inside the function using global. And you can change that. Maybe we can go through this alone. So here I have a outside global object 100. And inside this A100, I have referred it and I'm changing the X to until 10, right? So now when I call it, this global X is becoming the local X. Whereas if I do this, if I remove this global and I run it, it becomes 100 because this remains untouched. Only a new variable of X keeps created and updated, right? So that's the namespaces. Anything that you define inside a block, especially a function, is of that function. If you define it inside a class, it belongs to that class. This is not, the block concept is not the same for loops. Loops defined in a global context still refers to the global variable. That's what I mean by this. Here, you don't need global, local and all. It's only for the functions and classes. Yes, Abhishek.
Yeah, so if you have nested function and the variable is defined in like the outer function,
Mhm.
like can we change it in the inner function or should we like use global keyword for that as well?
Okay, let's try that. And then I'm going to move the whole thing here, right? And then someone has to call inner, which is going to be my A100. As you can see, nothing has touched this I. Let me print X also. Sorry, nothing has stopped from this being happening because it's creating a new variable. Now let's say I also have x equal to 20 and I call inner, after which I'll call X. Now this X got printed completely and then 20 and then 100, which means it's not touched. Now for inner, if I do global X, right? Global X, what will happen is it has to always go to the global, which means it went to the global. Actually, let me reduce this to 1. It has to go to the global and then change that value, which means this 100 has been changed to 0. This remains untouched. Now, how do I refer to this one, which is just one level above, right? For that, there is something called as non-local, where the global remains untouched. It goes one level up and brings that value. It's only one level up. If you have one more inner function, it will go to that level.
Okay.
Okay, this cold is killing me. But yeah, cool. Now, we have talked about everything being an object, which means functions are also an object. This is the second most favorite feature of mine. Once function become object, you can do all sorts of things with it. What do I mean by that? Here there are some examples, but I'm going to give you a lot of quick hacks that you can do. As I have told you before, I'm going to create some pairs of numbers. Let's say zip of, we need two lists. Let's say zip of range of 10, comma, range of 10. Okay, that's a zip. For I, comma, j in zip, print of I, comma, j. Now that's a bunch of pair of numbers. It's the same numbers, but it's okay. Let's try also -1 to, sorry, -100 to 10. No, -10 to 0. So now I have a bunch of minus numbers and minus plus numbers, right? Now, since functions are objects, you can have other data structures holding functions. I can have a list which has this add method. I can have a function, I can have multiple items Let's say you have A100, right? Let's also have A100 here. So you can have a list which has functions. What's the point of that? We all know that lists are iterable, which means you can do a for loop on that. For function in L, I can print each function and figure out what it is. Again, as you can see, everything is an add function. I can call that function with my zip values. I can call this function again and again, 10, 20. You can do all of this. Now let's say you have multiple functions, like you do something called as function chaining, right? You call one function after the other and pass the output. You can very well do that here. This is very interesting concept where if you have multiple functions which you want to call in series, you can put it in a list and then loop through it, call it, rather than calling add 4 times, right? Now, the point of that is to have add, subtract, multiply, divide 4 functions. You loop through this, you loop through this. In 2 loops, you have all the answers done, right? So this is the outcome that we want. Similarly, you can also have dictionaries. Another beautiful thing about dictionaries is we have talked about the vehicle class. Let's say you have I keep writing bar, car, bike, and truck, right? And for this, I have 3 different functions. Park bike. Similarly, I have these 3. Now I can create a dictionary which has car and then park car, bike, and then park bike. Okay, I'm going to leave it at that too. Next, I will write a function called park, to which I will pass the vehicle type. Now this is the this is not an object-oriented way, but this is just the functional way or a data structure way or a Pythonic way of doing it. Now I have a dictionary to which I will refer that D of vehicle type, which is my key, and then which will return, give me a function, and that function I can call, right? Let's finish this quickly. Park bike, def, park car, front of park car. Okay, let's write this. And now if I do park of car, it will park the car. It will do, if I do bike, it will do the bike. This is pure, why do we do this? Rather than writing if vehicle type equal to car, if vehicle type equal to bike, we can do this. This is called data-driven method of programming. You're using data to make this decision as to whether to call the car or the bike, right? So there are other ways to do this also. Rather than doing this, you also have, we saw globals, right? Globals will maintain a dictionary of all the things that you have in your global. Since we have written so much code, it's having all of this. So this is a dictionary. Don't worry about being all this. Let's do dot keys alone. Since it's a dictionary, I can do keys of. That still is a huge number. So to this globals, I can also do park car, which will give me that function, that function I can call. So what's the point of that? I know my vehicle type. Although refrain from doing this, don't do this in production. If I have a vehicle type car, then I can use globals to do this. This is not a production friendly code, which is why we do this. Because searching through globals, which is a huge list, is again performance implications. This is also a possibility. Now that's where we functions as objects, right? Now that we know functions are object, you can put it in a data structure. You can pass functions to other functions. We also saw one function can have another function, that is the inner function. You can pass one function to another function. You can have that function return another function. So that is all about decorators, right? Here I have a function called logger, which takes a function as an argument and then bunch of other arguments. Now, before calling the actual function that's being passed, I'm logging it, and then after it's called, I'm printing the value it's returning. So before I am calling add, I want to print the function and its arguments. After it's called, I want to print the value. So that is what this logger does. So this is kind of a decorator, but it's still not there. We have to do something else. Now you see, a decorator is a function that not just takes a function as argument, but also returns another function. Here it's not returning a function, it's just returning a value, which means you have to wrap the whole inner thing on a different function, which is getting returned here. I'm going to pause a little bit so that you're grasping it with me. We're going to keep increasing the complexity. First, we have a function called logger, which takes a function and an argument. Rather than calling the function directly, this logger function is going to do the job and then return you the final value. But that's not a decorator. This is not a decorator yet. For it to become a decorator, it needs to take a function as an argument and return a function as an argument. Because of that, we create an inner function. So we are wrapping a function and then returning an inner function. So by doing that, logger.add will return a wrapper. And that wrapper, you can pass the actual argument that you want to pass so that the inner function gets called and your decorator is completed. Now with a logger that has both function as an input and function as an output, you can use this syntax. This is a non-syntactic way, like the normal way. This is the syntactic sugar way. You can add the same logger to other functions also. Thereby it works. I'm going to pause here, answer questions because we haven't gone through this step by step.
So like this is like we did it for logger. It can be done for anything else as well, right? Like I see this as like middlewares that we define in backend systems where we want to perform something on certain requests, like all of them, right? Like if you want to perform auth, so like can we define that with every function definition that we do, like we are doing it for logger?
We can, yes, that's exactly what all the decorators that you see is. If you write a class and let's say I'm writing a dummy class, and to this I have there is something called as class method in Python. I'm going to make this a dummy method. This doesn't hold anything. This class method is internally a decorator, right? It has its own definition. In Flask, if you have written, you will do something like app.get off slash or something like this. This is again a decorator. App.get is a decorator which takes one argument. Decorator with arguments are also here. So let's say I want to pass a special function, then this is a little bit complicated. This itself is a function call, and that function call should return a function. And then for a wrapper, you need another function. Let's actually do that. It's a little bit complicated, right? This is also very good exercises for you to learn how to read Python code, right? You need a logger. Let's make this advanced logger so that you don't get confused. This is an advanced logger. The advanced logger takes only one parameter, which is a string, right? So it takes a message, which is a string. But we also want this to behave like a decorator, which means you know that it has to take a function as an argument and then return a function as an argument. So for first, let this return a function, which is an return. def decorator, right? This decorator will come back to this. Now this has to return a decorator. This decorator is the actual decorator function. This is just a function that takes a string. Decorator is always something that takes a function as an argument, right? So this is the actual decorator that gets returned as the result of calling advanced logger. So this is the, sorry, you have to do pass, and then this is the actual decorator function. The advanced logger decorator is the actual decorator function, which should return another inner function, which is a wrapper function, right? Wrapper. Now let's write the wrapper. The wrapper is the function that actually calls the function with the arguments and the keywords. So in here, you will actually call the function with the arguments and keyword arguments. Did I do? Okay, I might have done. So now advanced logger returns a decorator. If you call this, you can call this decorator with an add function, or let's say subtract function, which will return you this wrapper. This wrapper you can call it with your parameters, and then finally you will get the value. So all of this is happening by just writing this. So
This is like we have currying in JavaScript, if you are aware about that.
what is it called?
It's called currying. Like you can basically have multiple like functions written inside functions, and then you can just return a function which takes.
Sorry. Yes, that's exactly what this is. Currying is what this is. I have heard about it. So anytime you see something like a syntactic sugar in Python, don't get carried away, don't get scared. It's all internally objects, which means there is some way or the other to construct it. Now, you can also make a class behave like a function, a class object behave like a function. So this is a normal class, and this is a normal object. To make it more evident, int we know is a class, and then we have done int of 1 all our life. And then we know this, right? This is very similar to this. We know the segregation. But the moment I do x of, says int object is not callable. Even for list, it's not possible. But you can make your classes behave like a function by using this underscore method called call, right? What does it do? It doesn't do anything unless you give it a behavior. Calling object self, let's say. Now I can do n of, and then it calls that function. But before this, if I remove this and use pass, this is not allowed. So underscore underscore call will make a class behave like a class object, behave like a function. Now that behaves like a function, you can also pass function to it and make it return a function so that it behaves like a decorator. Now that class behaves like a decorator. Here you have a duck class, you have a duck object. And then when you call duck with, let's say, add, it behaves like a decorator to which you pass 10, 20, it quacks before adding and then adds it, gives you the value. So call makes the class behave like a function. Because it behaves like a function, you can pass and return functions from it. Because you can do that, you can make it behave like a decorator. And therefore, it's all objects at the end of the day. Everything in Python is an object. So it can now be a decorator also. Like you can use the syntactic sugar, exact syntactic sugar you use for a decorator, but it's a class object. Too much, yes. We can pause here. We are also off time. So there is two more concepts, context manager and the iterator and generator. Iterator and generator, I kept it for the last because there is also a detailed blog post I've written about it. So it's all given here. So you can go through that. That's the exact or somewhat similar kind of explanation I planned for this. The context manager alone, I will record a video and share it with you. You can ask more questions. That's why we have the WhatsApp group. If you're not there, please check your email. You should be able to join the WhatsApp group. But overall, if you have any other questions, now is the time. No questions? All confusions?
We have to play around with it.
Sorry?
No, we need to play around with it to
Yes.
practice it.
Since this is a
Then
very
we might get more doubts.
Yes, this is a very in-depth workshop, and we've covered a lot. I couldn't give time for you to try everything. So that's why you have the setup ready. So go play around with it. This is a playing around thing, right? Why does this work? Question, why is something working? Why does it not work? What happens when you change something? And then go through the error messages one after the other. Again, the WhatsApp group is there for you to try this on your own and ask questions and interact. So if you're not on WhatsApp group, I will share that with you. I will send another email with the WhatsApp group where you can ask these questions. Yes, try this on your own. Context manager, I will create a video and then I'll send it with you, for which again, you can use the WhatsApp group to chat. Any other questions on Python itself?
Okay, so I had shared a screenshot. I think I got that thing, but I found that very interesting. If you can open up now.
You mean the list.append?
Yeah. So I actually pulled that up like while playing around in that whole
Mhm.
document. Like there is this Python reference, right? Language reference
Mhm.
from there.
This one, right?
Yeah.
Yeah. So everybody here understands this? Let's see. Okay. For me, there's no way to. Oh, we can copy this now?
Yeah. Like, I can copy from the text.
Okay, I don't want to mess with the generators. Cool. That's a good place to start. Now, when creating a list, I can create n number of items by doing this. Maybe there's something wrong with the character because I copy pasted. Yeah.
There was one empty list inside that empty list.
Yeah. I'll come there. 1 star 10. Okay. So if I do this, the list will have, now you can see this is a multiplication operator, which means list has a underscore mul function, which does this, right? So it will create a list with n items. Now, if you take this out and replace it with an empty list, the syntactically it's kind of confusing. So if you can see there's an outer list and then an inner list. You can do this. You can create 10 empty lists. You can also do this with dictionaries. Right? And then it will be n dictionaries or n. Now this can also be a value and that will also work. So if you want to create n objects of similar type, again, because list can have functions, that can also be an option, right? Now, because it was list of lists, your L of 0 is an empty list. To this, you can do append because it's a list. You can do append. And then now if you print L, all of this is going to be L because again, like I said, the memory reference for this gets created before and a copy of that is made. This is literally a copy of all the elements. So this is why this is happening, right? So this list gets created, and then when you do start and a copy of that gets created multiple times, and this is true for dictionaries also. If you do dictionaries, there's no append, so we cannot see an update. Let's do update. L of 0 dot update of comma 10. You can see this is also happening. So this is why you have to be very careful in the way that you use lists and dictionaries because of the memory references, which is why we cover it as the first ever topic.
Like if I do say have a list of integers and I do operations on any of the element, it will reflect everywhere, right?
No.
Like
It-
if I create it by multiplication,
Sorry?
like if I create it via multiplication, then that list, like whenever I perform any operation on any element, it will reflect on each element, right?
Not really. Let's try that. I'm also intrigued to try it. L of 10, it's not going to. I don't have 10. Maybe I have 5 star 10. Here, you're just doing this. Let's reassign only by reassigning, right? Only by updating this. In this case, you're not updating anything. You're just doing a calculation.
Okay, okay.
You're not
Okay, if I repeat it, then it's gonna, okay, yeah.
even when you do this, what happens? This is an assignment, which means it's going to create a new memory address and then do all the optimization, right? So now if I do L, only that value is going to change because I'm only changing that value.
Mhm.
Whereas when I did L dot update, I'm changing the list inside a list.
Okay, okay. So that whole reference is getting changed. I
Hmm.
mean, like that memory location is getting changed, right?
Yes.
Cool, cool. Thank you.
All right. So feel free to share any feedback that you have. Again, thank you all for joining. I'm going to pause here. Ask for 15 minutes. I got my 15 minutes. So thank you all for joining. The rest of the things you will get a video. And